So my name is Grimm. Only a few words about me. I should not speak so loud. Only a few words about me. I'm since 24, I don't know it so exactly anymore. Since 24 I give Python classes. I really started with a 1 version, you see, it's a little bit old. Okay. Since around 28 I give C++ classes. Since 2016 I'm an independent trainer. Mainly for C++, but I have a Python history. And sometimes I talk about Python, because I love both languages. And only one little advertisement. Since April, I have a worldwide mentoring program running, because I don't believe that a 3-day classes is the solution to our problems. We lead a live learning process, or learning beside your daily workload, something like that. So if you're curious, I'm happy to answer. But anyway, so you know I have a long Python, I have a long C++ story. And what I now want to talk about, how you can talk from Python to C++ or C forwards, backwards. And I want to give you an overview, meaning I start simple and each time I add a little bit more. So let's start. So first of all, what is extending? Extending means essentially that you call from Python into C or C++. And essentially it consists of 3 steps. You have to convert the values from Python to C++, have to do your stuff in C++, and have to convert the values back. And when you do it in the opposite direction, it's called embedding. It's not so heavily used, but it's also sometimes really has a benefit. This means you convert the data from C++ to Python, and once more, just the other way around. Most of the time you do extending. Okay, first of all, why do you want to do that? Of course, you know this rule, don't repeat yourself. You have something existing in C++, why should you implement it once more in Python? Just use it. Second point, when you do Python programming and you have a performance issue and you measured your performance bottleneck, what you often just do is implement this stuff as a library, as a shared object, and just call it from Python and call inside the C++ functionality. This is an easy way to overcome performance issues. Python has a serious issue. Honestly, it's not so serious, but it has an issue. This is a call called GIL. Global Interpreter Lock. I only speak about the C implementation of Python. Forget about the other ones. Global Interpreter Lock. This means C has no idea of concurrency. It means when you call from Python C, what you do under the hood, only one thread can run at one point in time, because there's a global lock. And maybe you want to overcome it, and you could do it by implementing the stuff with multi-threading semantic inside in C++, for example. Third use case for this stuff. And the first one is something I will give a presentation in 3-4 weeks, which is also interesting. Assume you have big data and you have a lot of C functionality to read in the data and you want to visualize the data. Honestly, this is in Python way easier than in C++. You can use the Jupyter notebook or you can use the REPL, and this is extremely convenient. So you write a Python wrapper to import this stuff in Python, and then you can play with matplotlib or what else. This is also a nice use case, because once more, you are way more agile when you do Python. But you want to do the hard work in C++. So 4 use cases. Let's continue. I start with extending. Most of the time is about extending. And we start simple. Simple means, first of all, we need a shared library. Once more, I start simple, and then I use different tools, how you can do it. And there's a reason why it ends with PyBind 11, but anyway. What does simple means? Here is the stuff I want to create a shared library out of. Of course, you know it from yesterday, this is the old version of Hello World. But anyway, this is a C Hello World function. Header, source file. And now I want to invoke this C stuff from Python. First of all, I need to build a shared library. Or SO, or how you would call it in Windows, the DLL, Dynamic Link Library. All the examples I show you are built with GCC on Linux, but I also did this on Windows. This is pretty similar. Sometimes it's a little bit more complicated. But anyway, you can do it on each platform. All what I did here, you can also use on Windows to make it short. So what you first have to do is to create position-independent code, pick. Then I create a shared library, and only to see that it works, I created out of this shared library an executable, and you see it works. I can compile it, and now we have a hello world. I used just this shared library, but of course from C. But we want to do Python. This is the reason why we are here. So the first thing which you can do is, you know, Python has a statement which is called batteries included. Oh, let us make a small poll. Do you know how many libraries are included in the Python standard? You just install 3. The newest one is 3.11. Honestly, I don't know it, but I can say at least more than. Who has an idea how many libraries Python has? More, sorry? Only the standard, I don't talk about pip. In the standard, more than 300. The issue in Python is not don't to have it, but to find the right one, or which one you want to use. And this is one you should know. This is the ctypes library. This is a library which is built in Python. We have it since 2, so we have it. And this library allows you directly call from Python shared object or DLLs. Therefore, you don't have to do anything. You see, ctypes, this is the REPL. REPL stands for read, evaluate, print loop. It's a shell with a Python interpreter inside. This is REPL. And now what you can see, I can just load this shared library. I built it before, you see, SO. And then I execute it in a qualified way because I imported it qualified. This is all what you have to do. But of course, when you have bigger project, this is quite tedious. But anyway, here, have a look what you can do. The same thing works on Windows. You have to use a different instruction to load it. You load the libc. Because why? Because libc, the CNOS in libc is way faster than in Python. No, I don't know why. But anyway, you can do it. You load it, and then you can invoke libc time. These are the seconds since the epoch. If you don't believe me, calculate it. I don't know it. Anyway, you can directly use printf. This is a binary string, similar to an ASCII string. Hello world. You can use printf, and here you can say, this is a integral, this is a floating point number, and here you see something special. Python, by default, only supports integral data types and strings, and a double is neither one of them. Therefore, you have to specify using ctypes, hey, this is a double. Please interpret this as a double. This is what you get with ctypes. Now you can display it. But you can do it even more sophisticated. You can specify a function prototype, argtypes, and here you can specify the types you want to have with the next printf call. You see, char pointer, int, double. Looks a little bit like Hungarian notation, I hate it, but anyway. And now you can display it, you see? String, int, double, here we have it. Once more, this is built in. Nothing I would have to do for this. The same goes for the return value. This is string, how would I pronounce this? Anyway, this gives me the string until the first appearance of the letter W. But when I don't specify the return type, it assumes it's an int. And of course, this is not what I want to have. Therefore, I have to specify the return type, and you see it here. Rest type, hey, this is a C string, and now we have it. And now you can do both of it. Once more, this is a little bit tedious, but it works. When you only want to invoke a few things on your library, this works. This was the first step. No, I'm not sure if this is the most native, but anyway, this was the first step. Let's do it a little bit differently. Do it natively. I strongly suggest that you don't do what I do now, but it gives you an idea what's happening under the hood, which is, for me, I think, essential. Now I do it natively. Once more, this is my hello world. I want to have a module, and I want to invoke it from Python. And this is the extension module. You see, 27 lines, only the important ones. This stuff, I compile this stuff with a C compiler, and then I have a module which I can invoke from Python. So let's analyze it. First of all, python.h. This gives me the Python function, the C functionality. Essentially, you need this special wrappers to come from Python to C and forwards, backwards. Then I declare the function I want to invoke from Python. And this is, by the way, whom of you knows Python? And you know in Python the basic data type is object. And this is the C pendant to it. Therefore, you see here always PyObject. This is the native mapping. Okay, here you specify the C function, this is static. This is the method table. These are the functions you want to export. I only do it with one. Here I define my module consisting of this method table. Here's the definition of my C function, and here this is invoked when I import the module, when I say import hello world or something like that. This was the overview. Let me dive into the details. Python.h, you get it when you install python/dev. Then you get these headers. These are necessary. Must be the first header. A few C headers are included and a few additional stuff. This is necessary. All visible symbols starts with py, y written with small or capital letter. This is just a naming convention. This is the method table. You see, this is my method. This is the C function name. This is the Python function names. This is how I want to invoke it. This is the convention for passing arguments. And this is the doc string. Whom of you know what the doc string is in Python? Or as we would say, how would you call a doc string in Python? Dunder doc. 2 underscores before, doc, 2 underscore after, short, double under, way shorter, dunder. In Python we call it dunder doc. Okay, now this was extremely Python specific. There can be more as one, and here is the sentinel. Here, I only export one function, therefore I'm fine with it. Next point. This is my module. This is my module. Let's see what I do. This is the name of the module. This is the documentation string of the module, also dunder doc of the module. I always use here only -1. Okay, and this is the name of the method table we defined before. The module consisting of the method table. And now the final step. When you import the module hello world, by the way, you have to extremely careful to follow this naming convention rules. If not, you get a lot of crazy errors. So this exactly has to be called such as the module hello world. You see? These are really, really ugly errors. Sometimes on Windows, they want to have additional underscore, and so this is always a lot of fun. So, and this is the module. It returns a PyObject, as always. Here's initialized, and when you import it, this would be returned. This is your module. This is essentially all, but this is only a hello world. How would you build it? Of course, Python better is included. We have this utils, which allows you to create packages. And this is a minimal description of a package. It's not minimal. A few things are not necessary. What should be part of it is, of course, the name of the module, and second, that it's an extension consisting of this C file. And when you now call Python setup.py, this file is, by the way, called setup.py, and you install it locally, build extension in place, you have it. You can use it. So now we did it natively. Let me just have a look at my clock, because as always, I'm pretty fast. No, I'm just in time. And now I can import my module because it was installed in the same place. If not, a Python compiler would not find it. I can invoke it. I can look inside. And you see, here's my hello world function. By the way, in Python, under the hood, all is a dictionary. And what is that? The keys of the dict, not more. And then I can use this key and use it as a function, and therefore I get the result, hello world. Okay, this was native. I don't suggest that you do this, but it helps you maybe to understand error messages, to get an idea of what's happening under the hood. Let's go one step further. I looked it up a few minutes ago. There was actually a release a few days ago, a new release of SWIG. SWIG is a thing which makes this process kind of automatically. It's pretty old. It's from 1995. So pretty old. Its author is David Beardsley, by the way. If you ever want to listen to interesting talks, listen to talks about David Beardsley. It's unbelievable how skilled he is. But anyway, he is the original author of this tool. Stands for Simplified Wrapper Interface Generator. This means this tool allows you to create interfaces of interface definition description files, sorry for this word, and they can be created for different programming languages, including Python. Does anyone of you ever used SWIG? I assume it, yeah. In the past, it was heavily used, but nowadays we have better tools. This is even a quote from David. Anyway, this is the definition, or this is the declaration of my interface. This is all what you have to do. This is literally copied into the corresponding created file, and this is what this interface exports. You see, hello world, not more. This is a .e file. And what you have to do is extremely simple. You say swig -python hello world.e, and it creates two different files, .py and .rep.c file. And when you look at the numbers, you see the C file is a little bit bigger. Here, under the hood, all the stuff is done which I did before, essentially. This py stuff, py object, and stuff like that, and parsing. And Python has, of course, a big interface to talk directly to C, because it's based on C. And what you do is you invoke essentially this module, and this module is wrapped to this C file, and this is what's happening under the hood. So this is the low-level wrapper, and this is the high-level, which you would import from Python. You would say, import hello world. And it immediately wraps to the C implementation, which makes the magic, which I a little bit explained in my previous slides. How does it work? Of course, we need a setup.py file. Here's the implementation. You see, it's not magic, just a simple C stuff. By the way, the next step, I put a ++ behind, because we have a C++ conference. Okay, and this is what you do, such as before, and then you say import world. And now when you say dir, you see there's a little bit of strange things inside, which are usually not inside. But anyway, at least we have a hello world which we want to use. And this was the step. I could essentially use the setup.py file from the previous example. Okay, this was SWIG. And now comes my favorite. This is PyBind 11. This is based on Boost Python, but without the Boost dependency essentially. It's called 11 because it's based on C++ 11. But such as SWIG, I forgot to mention it, it supports many features up to 20. I'm not sure if any, but I think with 17 we are quite good. So it's fully implemented in header files, based on Boost Python, and you can extend and embed. I only will now extend, but anyway, you can do it in both directions. Call from Python C and also the other way around. By the way, not C, C++. Now we talk about C++. What can you do? Forget about it, anything. It makes no sense to put all the features I know about C++ on a slide. And have a look how nice this looks. I don't know why, and there's a reason why I now use the function add. You see it in a few seconds. This is first the C declaration, or you can also say, let me say C++, because under hood mangling is happening, so it's C++ essentially. This is a simple function, and this is my Python binding. This is all. To get the functionality, I have to install it, and I have to include it. This is called by import, this call here. Here, this is my module, M, and I bind something to it. What do I bind to it? I say, from Python, I want to invoke add, which dispatches to the add function here above, and this is the doc string, as before. This is all what I have to do. The building is a little bit more complicated, but they also support a CMake file, which makes it happen out of the hood. But honestly, I had an issue in the first tries with Windows before I found the CMake file. Because with Linux, you have special commands and makes it quite easy. But we don't have them with Windows. But anyway, there's a CMake file, and this makes this step happening. Okay, now I show you a few features. And then I show you how it looks like when I use it in REPL. And then I do really something C++ish. I create a class and do a little bit of class hierarchy. And to see how easy this is. First of all, it's a convention to use PyBind with this alias here. Just to know it. Because it's a little bit a long name. Second, it supports keyword arguments. How many of you know what keyword arguments in Python are? A feature we desperately want in C++, but we don't have. What are keyword arguments in Python? Who knows it? This essentially means when you have a function which has a first argument, function parameter which is called first, second is called second, you can call them by name. This is extremely convenient, in particular when you provide default values. This makes it extremely convenient. Let me say a joke. In C++, I would say having a function with more than 3 arguments is a code smell. In Python, we have, for example, the module subprocess for creating subprocesses. Do you know how many arguments this constructor has? More than 20. But you don't care. You have only to specify 1 or 2. You don't care. In C++, this would be horrible. Imagine a function with 20 arguments. You specify the first one, then you have to repeat all the default arguments which were written in the declaration. This is crazy, but not in Python. So what you can do is the following, and by name, and you can also provide default values. Once more, I implement the add function. And now I come to something which is really, really crazy. When you read here overload and you think about Python, is something here feeling strange for you? What did I say before? In Python, all is a dict. A class is also dict. The member functions are keys in the class dictionary. To say it specific, it's called dunderdict. Underscore, underscore, dict, underscore, underscore. And you know what? What is key of a dict? Sorry for this. That a key can only appear once. This means in Python, we don't have overloading of function. It's even worse. even we have a collision between attributes and function names. There can only be one name. Because under hood it's a dict. If you don't like dict, think about unordered map. It's the same, essentially. And you know what? We can make Python more powerful using PyBind. Now we can have a function sum which takes 2 arguments and 3. This is not possible in Python, but now it's possible because it's mapped to a sum function in C++ taking 2 or 3 arguments. This is for me honestly crazy. Python becomes more powerful with PyBind 11. And of course we can have attributes only to be complete. Now let me try it out. I say, this time I invoke it unqualified. You see, by the way, you should never do it, but I did it only for presentations. From function import star. Now I can invoke them. They are part of my global namespace, and I can invoke them globally, directly. I can say add. I can use them by name. I can use them without arguments because they have default values. I can invoke sum with 2, with 3 arguments, and of course I have 2 attributes in my module. Okay, now let's do a little bit more OO thingy. This is a class, human being, and this is the Python binding for it, or PyBind 11 binding for it. This is the entire stuff. Of course, originally in production code you have 2 files, but anyway. This is all. This is the entire functionality. You have a human being, it has a constructor taking a const to string ref. It has a member function which const return a const string ref and has a member to string. Okay. I use this abbreviation here, which I already mentioned. And this is my binding. Human. This is the name of my module. This creates a class. I bind it to modules. You see MM. This is the name of the class. And here's something interesting. This is a kind of describing, this is my constructor. Do you know the constructor in Python is called dunder init. Dunder, you know, I'm lazy, underscore, underscore, init, underscore, underscore. Dunder init. And this means, this is my constructor in Python, and it dispatches to the constructor in C++ having this signature. And additionally, I have a member function. Get name, this is the name from Python, and this dispatches to this function of this class here above, or member function. You see, this looks extremely, how should I say, readable or understandable. Okay. This is also something which I like about PyBind 11. Who knows what dunder wrapper means? Can you say it? Just cry. If not, I could do it. Maybe it's anyway. Dunder wrapper is a kind of output operator for Python. This is when you want to display something in a scientific way, or exactly, you overload dunder wrapper. When you want to do it more human readable, you overload dunder str. So once more. And have a look here. I define here dunder wrapper, which is dispatched to a lambda. This is extremely convenient. So now my data type supports displaying in the REPL, or to be displayed in the REPL, and when it's displayed, it says human being and the name of this human being, h.name. This is extremely convenient. I just annotate a lambda. Of course, you could also annotate any callable. I can have attributes which are read-write. They could only be read or could only be write. But here I used read-write. What I can also do is, I can do inheritance. I have a class human being, such as before, and now I derive woman from human being, and it has the same constructor. Also a constructor taking instead string. This looks extreme. For me, it looks, you just read it and you know what's happening. And this is way more sophisticated, such as the hello world from before. Okay, let's play with it. I once more imported unqualified from human import star. Maybe you don't know Beatrix, it's my wife. Anyway, you see, woman, Beatrix, so I create a woman. I invoke the constructor. Now I have a Beatrix. When I display it in the REPL, done the wrapper is called, which I mentioned before. And done the wrapper, what does done the wrapper do? Human being age.name. And this is exactly what we see here. Human being age.name. Then I display the attributes of this class. Once more, these are only keys. You see, there's for example here this dunder. Well, where's my dunder? Dunder wrapper. I forget to mention I also implemented dunder string. But anyway, this is the way Python implements operator overloading. It's heavily used in Python, but it works a little bit differently. What I do afterwards, I display the family name because it's read-write. I can also do it by invoking this member function getName. I can ask for the gender, and you know why I get this strange method, strange answer? Because gender is a function, not an attribute. Therefore, it just displays, hey, this is only a function. To use it as a function, of course, I have to invoke it. And here, when I say print bear, this goes to the dunder string, and this is the way I implemented it. I forgot to show it to you. So it just works. The main point here is the following. When you see this program, you have no idea. Let me see. You have no idea that under the hood, this is C++ functionality, which is just triggered. Even the attributes inside, I see here nothing special. This is all usual stuff. Yeah. Okay. As always, I'm too fast. But anyway, any questions so far? Okay. Then let me, because I'm too fast, let me say let me explain a short story about embedding. What I do now is extremely straightforward. But anyway, let me say a short story, what we did around 2022, before Boost was created or Boost Python was available. In my company, we had a big simulation software for car crashes. And this is a lot of data. Therefore, we had a big Qt, or Qt anyway, how we would call it, application to load the data, have a lot of different buttons and so play with the data, and then this was it. This was basically a job. You know what they did? I didn't do it. This was one of my colleagues, and I just used it. What they did was the following. They started the Qt application, which is of course C++. Each thing they did on the IDE was written down as a Python instruction. So you created out of C++ Python instructions. Then afterwards you let run a purifying script to make it a little bit purified a little bit. And afterwards you can start the application directly from Python, and you can automate it. Therefore, we use this tool to automate our tests, our GUI tests. Therefore, we loaded other data sets because we can. And this was really, how should I say it? Yeah, extremely interesting use case. And this is what you can do with embedding. You can embed a Python interpreter into your C++ application, and afterwards you can trigger your GUI from your Python interpreter, from the REPL. This sounds strange, but this is possible, and we did it. Okay, but anyway, I'm too fast. Embed Python. There are essentially 3 ways to do it. You can just execute a string, you can execute a module or a Python file, or you can execute functions. Once more, now we do it the other way around. We have C, and we want in this case it's C, and we want to call from C Python. First, it's extremely easy. Once more, I did it with GCC and Clang. The examples, the GCC in Windows, the examples are with GCC on Linux. Here's what I have to do. This is a C program. I have to initialize and shut down the Python interpreter. This is all what I have to do. And here, you see, pyrun. This is stuff which we got from this python.h file. And here, what I do is, I just execute this string here. Import time, print time, C time. You see, these are Python statements. And when I compile it and when I execute it, this happens. Showtime. It's not so interesting, but you can do it. So I started a C program which triggers a Python, which starts a Python interpreter and does some Python thing. Okay, what can I also do? I can do it. I can let run a module. This module is called showtime.p, and this is what I want to invoke from C. Now, almost the same stuff, but inside a module. And what I have to do is the following. Oh, wrong button. Once more, python.h, I need the C header. I initialize, I shut down the interpreter. I open the file. I check if this opening was successful. If yes, I execute the Python file and I close the file. The entire module, just execute. And now to the most sophisticated part. In this script is a little bit, C file is a little bit more sophisticated. I have it, but I don't have it here as part of my slides. And now I want to do something more complicated. This is a Python script having 4 functions. We should count correctly, 3 functions. Faculty, sum, and product. First of all, I display, you know the syntax, this is pretty similar to the C++ format string syntax. Other way around, format string is based on this syntax, but anyway. What I do is I just display return faculty of and what is here inside. So, and then I calculate the faculty using this functool function, which does which calculates the faculty of a function by doing recursion. By the way, we have reduced in C++ since C++ 11. Before C++ 11, we call this accumulate. Just that you learn also here a little bit about C++. Okay, then I do a little bit of sum, and I do a little bit of product. And this is now the Python function I want to use from C. Here's how I use it. I will explain the details later. This is a C function which invokes this script from before and says perform faculty with the argument 10. So what should I do to make this happen? To run out of C Python. Second, this is the output produced by Python, and this is the output produced by C. And the result here is calculated by Python. What do you have to do? Here are the steps. Let me see. Okay, I have it more clear. First, you have to read the command line, of course. You have to read from C the command line with a lot of these py instructions. Then you have to extend the syspass. Syspass is the module search pass in Python. And I don't know why it should be, but in this case, it will not look in your local directory where you invoke the C function. Therefore, you have to extend syspass. Syspass is under the hood a list, and you can extend it to additional pass things. Third, you have to import the Python module, of course. I only specified I want to have it. You see? I only specify I want to have it. My math. Fourth or more. Anyway, you have to pass the function arguments. This is a string, this is an int, what else? Then you have to call the Python thing, and then you have to use the results from the Python function in C. These are the steps you have to perform. And here are more details. You see all Py. First, I import the sys module, because sys has the function path, which gives you access to the module search path. Then I extend this path with my local directory. You see the point here, which should be part of this path, but in my case it was not. I don't know why. Then you have to import the Python module. You see, arg for 1, and here you import it, py import import. Next, you have to pass the function arguments, the command line arguments. And here, py long from long. What you do essentially here is, let me think about it. You have it from C and you want to prepare it for Python. You have also to think in which direction it goes. Then you call the Python functions, you see, pyfunc, from here irgendwo above, as it was before. And then you display the result in C, which you have from Python, p-value. P-value is created here, and now you have it in C, but this is under the hood calling this Python thing. And this is embedding, so the other way around. And of course, this is a file of 40, 50 lines, but essentially it looks this way. Okay. Now I have an issue, because I'm already done with the stuff I want to tell. So I'm a little bit too fast. Anyway, this was extending embedding. I strongly suggest that you use PyBind 11 when you want to extend something, because it's extremely convenient. Even people are involved in this project, which gave presentations here, such as Boris Schelling, which a few of you may know. And it's extremely easy, extremely convenient, extremely readable, and extremely powerful. What should I say? And it just worked out of the box. The only issue I had was the build process. But after I found CMake, by the way, whom of you used PBind 11 in the past? What was your experience? Now we are on the open question and answer phase. Any addition to my remarks about PBind 11? Any things which didn't work the way it should work? Okay. I also gave you the example about embedding. It was an extremely simple example. Therefore, I wanted to give you an idea what you can at least achieve. Think about this example. Automate testing of GUIs in C++. This is not an easy job anyway. So, once more, I'm done with the stuff I wanted to tell you. I'm a little bit too fast. I don't know why. No, it's always been the case for me. So, I'm open to questions. Okay, thanks a lot.
Okay, I have a question. So before you start talking about embedding Python, you mentioned a Qt application.
Yeah.
And my question ties into that. I wanted to ask you if you're familiar or have heard of PySide, Qt for Python. So
Py what? Once more?
PySide. So PySide, like the left side of the room. Qt for Python, which is Qt's own solution for extending and embedding Python. Full disclosure, I'm from the Qt booth. I joined that team that works on Qt for Python a few months ago. So ulterior motives for the question.
No, honestly, I don't know it. But anyway, what I often did in my past was to use PyQt. This was only thing between Python and Qt I did in my past.
Well, Qt for Python is pretty similar to PyQt. So I'd say PyQt is our direct competitor. But the idea of PySide is we have So we have a binding generator. We have a type system. You have an XML file where you specify type system. You specify which type maps to which type, or if you have a function signature, how that signature maps to another signature. You can inject code into the for handing ownership from Python to C++ and vice versa. And then you can generate you generate a wrapper. You compile a wrapper that is then compiled with a library, and then you call it from C++. It's the binding generator is not exclusive to Qt, so you can use it for any other kind of C++ library.
A good point I forgot to mention. Of course, this binding is worldwide used. This is one of the reasons Python is the success story regarding programming language of the last 20 years. Because under the hood you have always extremely fast, but maybe sometimes a bit ugly C++ stuff. But now you have Panda, you have this NumPy, this entire numeric stuff, and this is, I think Python is now I hope this is the English term, frankly, the language you use when you want to create a binding, you always start with Python. Do you have to add something? But I think, do you have to add something? But I think this is also what you see. Python is the language you support when you want to add, when you want to open this language to this library to something else.
Yeah, no, I agree. I mean, Python is such a vast repository of
NumPy, SkyPy, Panda, this AI stuff, and this is all based on the hood. You have C++ stuff, but you have an extremely nice Python layer.
Would be a shame to keep those exclusive to Python, right? So why not allow other languages to use them? Yeah, so I agree. I think I'll hand the microphone to the next person.
And at least you can see from my talk how easy it is to interact. Even Python supports it natively with ctypes.
So hi, thanks for the talk. Very interesting. It's really straightforward. I have a question. Even with PyBind, you have some boilerplate to write, and I'm just wondering if there is a tool like SWIG, for example, which maybe you give it just a class definition, a header, and then it outputs most of the boilerplate already generated, and then you only fill the holes.
I don't agree with you, honestly. With SWIG, there's a lot of things you have to do. You have to do a lot of additional, how should I say it, special instruction to make something happen here. But with PyBind 11, I think we are quite close to the minimal stuff we have to do. I think maybe you think about a header parser which creates you something out of that or something like that.
Yes, exactly. Something like this.
I don't know. You have to write it. Now you have to do, and next year you can give a presentation here. So I don't know it.
Okay, thanks.
In the back. Would be a nice idea, by the way. There's one. Which one?
We recently have been using binder.
Py?
No, just binder. Like bind, but binder.
Okay, bind dev. Just as binding something.
So
okay.
You point it to your headers, and then it generates you PyBind level.
And on which C++ version is this based on? I don't know. No, sorry. Too late. So he just say he don't know it. Sorry. But this sounds interesting. This would make this thing a little bit easier. But I don't know it, and I don't know how good it is, what it supports. Sorry.
I have one question regarding debugging. Can you recommend or what do you use to debug the control flow between Python and C++?
Good point. So far I never did it, so good point. I cannot suggest here anything, but so far I had no issue. Is it good? Is it bad? I don't know.
Well, sounds good.
It sounds good, but on the other side, it's not an answer. So what should I say?
Okay, no, I was just curious.
For me, it's extremely intuitive, honestly. And when I would have time, I would really, in the future, look inside this implementation of Python 11, because I'm curious about which C++ techniques they used under the hood. But I assume it's pretty sophisticated.
Thank you.
I have also to admit I'm a C++ expert, but I'm not the Python expert anymore, such as I'm in C++. But I'm at least good enough to give classes anyway.
Yeah, thanks for the talk. We use Boost Python at work, and we always wrap C++ classes. And my question is, how do you deal with out parameters of functions?
What do you mean by out parameters of functions? What is special in this regard?
If you want to wrap a C++ function which has an out parameter and you want to get it in Python after you called the function, we only found the solution to return a basically transformed list containing this out parameter.
Can
Does
someone
it
help me?
make
I'm not sure what he means. You noted? Do you know what he means? Could you help me?
For example, a non-const reference parameter.
Which are
Or-
part of the return statement anyway. What is the issue? I don't get it.
So you have something with reference, and then how do you get the value?
We call
Yes,
them in-out
exactly.
parameter, not out parameter. We call them non-const L-value reference, you mean?
Yes.
We call them in-out parameter. Now I have it.
I'm sorry. Yes.
Out parameter is clear for me, but now at least I understand the question, but I cannot give you the answer on it, honestly.
Okay.
But once more, officially they're called in-out parameter. This is a non-const L-value reference. In vector, which you modify inside, and the caller should see your modification. And you have to do it by non-constant L-value reference because you want to modify it, and it's expensive to copy, something like that.
Exactly. Yeah.
I know the reason. No, sorry. Good point. I will look it up but today I don't have an answer. And this is an issue with Boost Python. Boost Python.
The issue is that we have to transform the function to return basically a tuple or something, Python tuple, Python list, so that we get all the out or in-out parameters.
Okay, this is a little bit
And
cumbersome.
it's ugly. Yeah.
Cumbersome anyway. 2 weeks ago I met Dave, but now it's too late. So the author of Boost, Dave Abrahams. Okay, good point, but I will look it up. So essentially in-out parameter in Python 11. Mm-hmm.
Thanks for the talk. We saw some cool magic with converting, like with making object-oriented code, but does it also possible to make something similar for template functions or template classes?
Yeah, of course you can also do a lot of stuff with templates.
And how it will be possible to code from Python then? I mean,
Honestly, I never did it, but this is just written in the documentation.
so
You can
okay,
use
so
it.
should be possible.
And
Okay.
by the way, it's based on Python Boost. On Boost, Boost sometimes use a few templates. I assume this works anyway. I never tried it out. What I did was I started simple, just want to describe the process, and I ended with Python 11. And this is what so far I tried out and worked out of the box.
Okay, cool.
So there should not be any issue. I only know that in SWIG, you have an issue with templates. You have to explicitly instantiate them. But in Python 11, they will not mention this. Therefore, I don't think there is anything here. So SWIG also supports C++, but they do it a little bit more complicated.
Okay, thanks.
As far as I know, the Python has a reference semantic.
Python has reference semantic. It's a little bit more complicated. Please go on.
Okay. So the question is it possible to bind non-copyable types from C++ to Python, like unique pointer, for example?
You can do it with unique pointer. You can do it with. You can even do it with SWIG, so it's supported. I see no reason why. But you say reference semantic.
I mean, if you copy then this object inside Python, what will happen in C++ code?
Once more, how would you start? You start from Python, and what do you want to do?
So I start with C++ and I have an object that contains a unique pointer as a member. And then I wrap this class and propagate it to Python. Then in Python, I instantiate this class and then make a copy of this object. But since inside there is a unique pointer, in C++ you cannot simply copy this object. And if I copy it in Python, will it be a reference semantic?
This is a little bit complicated because here are the languages a little bit different. Python, first of all, Python reference semantic, it depends. When you have immutable data types, such as numbers, such as strings, they have copy semantic. So when you assign one to the other, you get a new copy of the thing. But when you have multiple things, such as dict, list, or classes, they have reference semantic. And therefore, it's a bit more complicated in Python, or different. But this will not answer your question. Honestly, I cannot give you a definite answer here. But once more, Python is here a little bit special. And the reason is you always have to consider, is something mutable or immutable? And either it has copy or it has reference semantic. Either you work on the element when you want to change it, or you give something new back, more in a functional style, such as for a string.
Thank you.
Sorry. Now you see here my limitations.
Hi, so maybe I didn't notice this during the presentation, but I have a question about embedding Python. And the question is like, if you are building this, your executable, then the Python interpreter is actually like linked to your executable, or are you calling the interpreter that's already installed on the system, or what is this?
Of course, you need a Python interpreter. Without a Python interpreter, it would not work. And it's called.
So it's the interpreter that's already installed on the system where we are running the executable.
When you execute the C thing, you have to call it. It have to be found.
Okay, thank you.
But you can do a lot of crazy things with a Python interpreter. What we often did in my past was, I had customers who want to use Python, but you know, in specific companies, you cannot install anything. What you can do is to make a thing which is called frozen Python, kind of, which it means essentially you have a Python module, and you also include the Python infrastructure. And now you install on the customer side in main memory a Python interpreter. So not on the locally. So what you get essentially is a zip file which is in place expanded and in place invoked, but it runs in main memory. Therefore, you can use Python without an installation. And probably you can do some crazy things also here, but I don't know how. It's typically called frozen Python. There are many projects which uses this technique. I'm not sure what is nowadays used. I used it 15 years ago, but it was there possible.
Yeah, so my question kind of follow-ups on that, and you kind of asked it. Could you just get an executable with just everything and statically link in the whole Python, and then you can just give it someone and say, okay, this is just a binary.
This is exactly what I meant, yeah.
But you meant you have to deploy a zip, but you also have to...
the zip which is in place expanded, then it invokes some magic stuff inside. I don't know if this is now more easily be doable, but there are additional tools in Python which which detects which of the Python modules you actually need to let this run, so you get a minimal executable, and it looks like executable, but it's a Python runtime with your application, and which now runs in main memory. And this, for me, feels like an executable. It's a little bit of magic under the hood.
Okay, thanks.
And once more, we had to do it quite often in Daimler, on Daimler, for example, because you could not install anything. And a process to extend this infrastructure with a Python runtime would at least take years in these companies.
Time
Okay,
is over.
he said we should stop, which is also not bad, because now we can eat something. So, thank you.